Hi, I'm Jessa, and I love teaching math. Let's get started.
All right, welcome. So we're continuing our topic of distribution. So possibly you have seen this before. Maybe you need a reminder, or maybe it's the first time you're working with this. But we're going to do an example like this. We're being asked to multiply x plus 1 times x plus 2. So these are the things we're looking at. There is something called foiling, which is a mnemonic. It's a memory tool to remember how to do this process. So you may have heard of this term FOIL. Maybe there's this memory far in the back of your mind that's kind of sparking. So the way this is often taught is that you multiply the first two terms. So that would be x times x. So x times x is x squared. Then you multiply, let's switch colors again here. Let's see if I have enough colors. The outside two terms, so the outside is x and the 2, right? So the outside two terms here. So x times 2 is 2x. Then you multiply the inside two terms, so that's the 1 and the x here. So that's plus 1 times x. You can leave off the 1. Usually we don't include 1 if it's kind of implied. So I would usually write 1x as just, x. And then we have the last two terms. So let's switch back to red for this one. The last. So the 1 and the 2. So 1 times 2 is 2. And then I would simplify this because these two terms here, they both have x's, and so I can combine them. So I would end up with x squared plus 3x plus 2. It's like saying we have, 2 apples plus another apple. Well, that's just 3. Okay, so that is one way that people usually, that it is often taught, that you do this kind of what's called foiling process in order to accomplish this. But I like to also think about this as visualize it as an area problem. So let's consider a rectangle. So I have a rectangle, and it is of length x plus 1. Well, let's do width x plus 1. So this width here is going to be x plus 1. And this length here is going to be x plus 2. So here is a rectangle, and we have these two components. I would like to find the area. So the area is length times width, which for us here will be x plus 1 times x plus 2. Now, we're going to break this down a little bit more, but this is essential that we are recognizing that this area problem is the same as the original problem that we've been given. So I'm going to rewrite this rectangle, and I'm going to assign some lengths. So let's assign this length here. Oh, here, let's switch colors. Let's assign this smaller length here to be x, and then this length here to be 1. So the full width is going to be x plus 1. We have the two smaller pieces. Then let's go up to the top, and we'll call this 1, and we'll call this 2. Oh, I apologize. It's not to scale. Should have made it a little bit shorter. So here I have, inside this larger rectangle, I can build 4 smaller rectangles, and I can look at the area for each one. So the total area of the blue rectangle is equal to all of these 4 smaller rectangles added together. And so I can add those 4 together and then in that way achieve the larger area. So let's consider it. I have my first box, length x, width x. So x times x is x squared. That's my area. I have this smaller box here with 1, length x. 1 to x times 1 equals x. Then I build here. Again, I apologize that it's not to scale. This length is 2, but the width is still x. So 2 times x equals 2x. And then my lower rectangle here, it has width 1 and length 2. So 2 times 1 equals 2. So these are the 4 things that I add together in order to achieve the blue area. So this larger area here is equal to the sum of each of these 4 smaller areas. So the area is equal to x squared plus 2x plus x plus 2. This is starting to look familiar, right? Because it's what we did above. I can combine these two terms into 3x as they are equal to 3x. And I have the area is equal to x squared plus 3x plus 2. So how I would write this if I were asked to distribute is I would say, well, this original component, x plus 1 times x plus 2, is equal to x squared plus 3x plus 2. So we have here, in more than one way, we're able to achieve this answer. So there will be a couple more videos on distribution, working up some additional intuition for this and working on more complex examples. So go ahead and view the playlist to see some more of that.
If you have extra questions, you can go ahead and post them in the comments and I'll try to answer as many of those as I can. Thank you so much for watching. Please subscribe to get more help with math and see more of the math content.